Привет из Дубая. С вами передача «ГолубьМира», где разбираем крутые навыки. Спрашиваем на английском, отвечаем на русском. Подтягивайте язык или смотрите перевод в тайм-кодах. Let's talk about information theory and let's start with the definition.
Information theory, this is a part of math, this is science which describes and make researches how to conduct information, how to store, how to restore, and this is about modeling. We will use not a real word, but we will use some kind of model, economical model, mathematical model, physical model, chemical model, and then we'll start to modeling to understand how these subjects will behave in timing. This first level. Second level, we will think how to compress information. You remember we write an article about Huffman code. This is from Theory of Information, how to put a large amount of information on less space, not just to store, but also to conduct through the wire or through the air. Third, theory of information also will work with theory of probability and mathematical statistics to prevent of misunderstanding. For example, I am trying to use Morse code, and you will catch it by your eye, by your ear. And if I will make an error, maybe there is a way how you could make correction without asking me. So it's like a bulletproof coding.
So it's actually an interesting case when you're talking about the Morse code. There was a video where one of the person who was in a Vietnamese prison, he actually communicated by using Morse code by blinking. So he said the word torture while he was saying some nice things about the regime and stuff. And there is also an interesting point to make. Like when it comes to theory of information, it's also will be probably great to put it on the map to understand what is needed in order to at least understand and grasp head around and what kind of other theories it might be working nicely in conjunction.
First, when you work with information, you should avoid misusage and misunderstanding. So there is multi-meanings words. If I am not wrong, the English word set has 120 meanings. So if you will use it, it will fall to the fault. For example, the same word in Russian is косой. По песчаной косе шел косой, убегая от бабы с косой. And there is the same saying, but different meanings. One is tool to cut the grass. One is way how to put your eyes. One is the way how rabbit looks. And one is how the ground or sand in the sea could be named. So first is about use single meaning words. Second, this is how to predict what will say person, how to give a right answer. For example, you will ask me, what is the time? And I should understand from the context what you are asking for. For example, it could be astronomical time. Right now is astronomical time like this. Or I will say you, we have 5 minutes left before train will arrive. So you're asking not about time, but how many time do we need to get to the train? Or maybe you will ask when our plane will be landed. So I should understand. Third level is cryptography. How to put information in such a way that people without password, without permission, will not access it, if even they will intercept it.
And when it actually comes to exchanging of the information, the way I do believe it might be working is also have some sort of like an agreement on the interfaces, on the protocols, or like maybe even the way of communicating. So how we should go about it here. So for example, it's also might be working in a digital world, or it's also might be working in a physical world. Let's say there might be certain traditions where actually, let's say in Japan, I have to use the special notation to address more senior person so that the information that we exchange will have a slightly different context and connotation. So how the theory of information handles this part.
Yes, you give a right example. There are several things in theory of information which is complicated enough and is developing even right now. You know, in contrary, all mathematical equation already solved, almost of them, but not in theory of information. It's call, for example, for human vision. or animal vision or insect vision. We have different visions, and if, for example, we want to fight with bed bugs or with cockroaches or with some bees, wasp, asa, yes?
Wasp.
We should use a different color. Second, it's about neurobiology. Sometimes you could give signals, informational signals by sound, which are applicable for some age. For example, there is also a test. We will use special equipment and we will put a noise, for example, which are quite loud for 10 years boys and girls, and then we will go through the scale, and suddenly this sound would disappear, and it will help us understand at what age you are currently. So different ages couldn't hear some waves of sound. And third, it's quantum calculations. When we try to make a binary calculation, it is easy one, but its work do not well. The reason is the major constants in our universe is P, which is equal to 3.14, and also E, which is equal to 2.7. They are close enough to 3, but not to 2. So math which would use not the binary by triple code would be much applicable to coding, to conducting, and to storing.
And when it comes to having the object that actually would receive, store, and maybe exchange the output or the outcome of the processed information, so how this theory covers it, if it covers it at all?
Yes, it covers. You know, this theory also think about linguistic. For example, you will write an article and I will try to rewrite it. You wrote this piece, a masterpiece in English, and I will translate it to Russian. And usual systems will not understand this is translation with small changes. But theory of information would use theory of description to understand this is the same context. This is выявление плагиата. To eliminate
plagiat hunting or elimination.
Yes, correct. Yes, plagiat hunting. Nice phrase. Second, it's image recognition. For example, we have a lot of photos on our hard drives, and maybe they are slightly different. For example, you are making photo of girl, and some photos would be with a blinking eye, or maybe with размытый movement. Blurred movement. And theory of information could help to find these images and to eliminate even without asking. The same with doubling. If you have completely same files, for example, which is made in Microsoft Word, it is easy to compare. Use just file compare command. But if you will have music, one is, for example, AV format and another in MP3 format, you couldn't understand. Their contents of these files completely different, but there are a lot of different programs which are using theory of information, and they will understand this is the same music which is made with different coding.
And when it actually comes to using this theory, well, probably we already kind of like covered some of this aspects there, but how people actually may misinterpret or like misuse the knowledge that they have in order to make a wrong decision.
You know, Maxim, I was very happy when we started with you to write several articles about algorithms, how to achieve data, because a lot of people who are working in huge companies, they never think how to store the data. And, you know, it's lead us to a situation when you have lack of storage capacities, lack of channels, lack of memory. And if you know how to store data properly, you will make it not as pleasant for you, but which is suitable for algorithm. Algorithm, it is a way how to, in a most productive way, deal with information without memory spending, without wasting of the space.
And you also mentioned that the theory of the information is still like being developed. So what is the foreseeable future, or what possible directions in which this theory could be probably evolving?
I will gladly answer this question. For example, several months ago, we suddenly realized that our site of School of Troubleshooters again exceed the limit, and we should pay much more. You know, when you put site on internet, you had startup package which is 5 gigabytes. Then you will buy 5 more, and after you will go, for example, for 50 gigabytes, which is more expensive. And suddenly we realized that we should go on another packet, and it would cost us some money. And then I realized that we use PNG, portable network graphics images, and I realized that I learned that approximately 13 years ago, if I'm not mistaken, in 2010 year, how to say, 2010 год?
2010.
2010, it was research made by Google, and they created another way how to compress information, digital information. It's so-called web format, WEP. And I use this. And you know, all graphical files, they became 10 times smaller. And now we have at least 5 or 6 years to expand our data on the same package we use now. So how that happened? You know, when our computers were slow, it was much easier to download data without compressing. But now our computers so fast and channels so wide that better to use very severe compression to send this information and decompress on your local computer. And in this case, if you have a powerful CPU, you will get nice images which cost you not too much volume.
Well, I guess this knowledge is also helps like in a way to how to optimize things that already kind of seem to be optimized, and maybe even challenge the status quo, because like who is the person who defines the status quo? My last question will be how knowing about the theory of information could help to make this world a better place.
When you're trying to describe something, to manipulate with this information, we are going to create models. And if you will use very simple models, and after we will process them, we will get not so many rules. The complicated models we're using, the more time we spend on modeling, we will be closer to understand nature which surround us. It's, for example, about fishes. How fishes, when they're scared by the shark, they go for different directions, but they are not bumping each other. Or for example, how leaf trees, they know how to grow, and for each leaf there is enough of sun. For example, how these mushrooms understand what is the time to go out of the ground and to catch the nicest weather they can. We don't know. And the same with many kind of information. You know, the last time I was using theory of information, it was several years ago. It was a very strange story. I was asked by one ecologist to help. There is so-called 52 whale. There is a whale who was trying to make songs on frequency which are not common for other whales. And if you will look in internet, you will be astonished how many information about this whale. So a single way maybe have a damaging voice system, and he couldn't summon anyone. So he was singing just for himself. And suddenly we realized that there are several such waves in ocean. So we were using just theory of information to прошерстить информацию.
Scan.
To scan the information to find if there are any other creature which could listen to the songs. And suddenly we realize this is not one whale, there is at least several.
Иногда, если мы будем смотреть на данные с различных призм, мы можем найти очень исключительные результаты. А мы рассмотрели навык теории информации и чем он полезен именно вам. Всем мира.